Hello and welcome to another one of D's ADD videos. Today I'm going to be looking at the concept of rotational kinematics with constant acceleration. To make life easy for you, the best way to approach this is to compare your linear equations that you have with constant acceleration to the ones with rotational. And if you can make certain analogies, you will see parallels that appear. What are these analogies? Well, let's think of linear distance. What's the equivalence of linear distance traveled when we're rotating about a fixed axis? Well, if I start at this theta, right here, theta 1, and I move counterclockwise, I get a new angle, theta 2, and that motion that I changed was my theta. So x is analogous to theta. The linear velocity is analogous to our angular velocity, and the linear acceleration is analogous to the rotational acceleration. Once those analogies are made, you can come up with these equations pretty quickly. Velocity in the x direction, this could be in y, doesn't matter, just velocity in general equals initial velocity plus acceleration times time. Well, since we're doing rotational coordinate system now, we're looking at angular velocity equals initial angular velocity plus angular acceleration times time. The same can be achieved with the rest of these equations, having their counterparts in the rotational system. Okay? So if you're not familiar with the linear stuff, go back and review it, okay? It'll make your life with the rotational equations much easier. The final thing I'd like to touch upon is the link between the rotational velocity and the linear velocity allows us to come up with a couple new equations. So if we know that velocity equals the radius times omega, which is the angular velocity, the tangential acceleration then becomes, in terms of rotational kinematics, the radius times alpha. Whereas the radial acceleration will become omega squared times r. If you remember, the original counterpart that we discussed on a previous video when I first started talking about rotational kinematics was that it was v squared over r. Alright? So don't forget that the radial acceleration sometimes can be referred to as centripetal acceleration, but that's basically it. The main thing for you to do is just do a bunch of these problems, and you will see that it's pretty much like these. You'll need to figure out what pieces of the puzzle you're given. Once you figure out what pieces of the puzzle you're given, then choose the right equation that contains all the pieces of the puzzle that you have and the one that you're missing. And then solve for that variable, plug and chug, alright? So the practice is the key. As always, check out the example videos. Thank you and have a nice day.